This is Engineers Unplugged. All right. Hi, everyone. I am Lauren here for Engineers Unplugged, and I have my buddies Blake and Sam here, and they are going to, what are you going to talk about?
This thing called wireless technology.
Cool beans. All right, I'm going to let you to it, and I'll see you later.
Alrighty, so we wanted to give you a quick little overview of 802.11ac. Everything about AC now is speed, gigabit Ethernet speeds down to your wireless client. But there's an issue with wireless, isn't there, on when we try to do a design?
Sure, yeah, well, there are several issues, but of course the one we're talking about today is, the advertised speeds and feeds of gigabit Wi-Fi have some channel implications from an RF spectrum perspective. And so, regardless of where you're at in the EU or in the States, we only have a finite amount of spectrum to deal with, and how you implement AC in order to get and achieve those gigabit speeds can severely impact your overall deployment.
Right, and so let's kind of go to the whiteboard here and let's draw this out. When we're talking about this, we're talking about the channel width. And this is an issue because we only have so many channels, like Sam said. So if we take a highway, for example, traditional highway, well, we had an 802.11n, one lane. So then, in regular 802.11b, G, and A, we had one lane. Now in 802.11n, we gave ourselves 2 lanes for 40 megahertz, and that increased our speed. But
yeah,
with AC?
And so more correctly, the first lane would have been like this, just one lane by itself. And 802.11n gave us the ability to add another lane on, right? So we actually stretched the freeway and made it wider. But remember, we only have so much whiteboard that we can consume here. So 802.11ac, you're right, in 802.11a, B, and G, we had 20 megahertz lanes. 802.11n gave us the option of rolling that out in another 20 megahertz lane to give us 40 megahertz, right? 802.11ac allows us to do that again in the first wave 1 of the specification. We'll go that way.
So we'll go over onto this side now, so let's...
So we're going to add another 20 megahertz and another 20 megahertz for another 40 megahertz. And we're going to join these together for an 80 megahertz wide channel, or 8 lanes of a freeway, right, of a highway.
So why is this a problem? What we're looking at here is we're giving a Ferrari the right to go as fast as it can, but what about all the other devices out there, the Toyotas? We want to have equal opportunity for everybody, and we don't have enough space to do this in 5 gigahertz channel widths on a high density deployment. Is that the problem?
Yeah, absolutely. So you only have a certain amount of space in the spectrum available to build your roads, and you can build, you can take one AP and you can make it 20 megahertz wide, and you can fit more APs onto your deployment, or you can take one AP and make it 80 megahertz wide and consume all of this available airspace or spectrum. Right?
So essentially what we're talking about here is we're talking about the total aggregate throughput for everybody, not just one client. We want to be able to have everybody have a quality of experience on the network that is better than just giving one person the right to be able to go as fast as they can. Because let's be honest, how many people are out there streaming video that need a gigabit throughput down to the wireless client? Not many. Most people are just doing email and internet. So it's very basic low-speed technology that we're still working with today.
Yeah, absolutely. And that's not to say that there aren't 802.11ac benefits without using wide channels. You can deploy 802.11ac wireless on 20 megahertz channels or 40 megahertz channels and still get modulation improvements and still get a significant speed improvement, but you really want to be careful about the marketing gigabit Wi-Fi terms and how you can actually deploy that in the real world, because once 802.11ac wave 2 comes, the problem actually becomes exacerbated, because instead of going up to 80 megahertz channels, we can actually go up to 160 megahertz channels. So I'd run off the whiteboard here. But when we talk about channel bonding and space available to us in order to achieve those speeds and throughputs, you have to be really careful about what that means to your overall spectrum.
Yeah, it's definitely going to be an interesting time to see what happens with 802.11ac technology. How do we use this in our design scenarios? What's the implications of this? There's a lot of things to take into consideration, and like Sam said, the main thing to focus on is don't get hung up on the marketing technology terms of saying this is going to be gigabit speeds, you're going to be deploying this, because most times we don't deploy this in our designs.
Yeah.
We stick in our 20 megahertz, maybe even 40
Maybe
megahertz.
40.
We don't go to 80 megahertz. It's just not beneficial to everybody.
Yeah, absolutely. We have a lot of coexistence issues to deal with our neighbors playing well with each other. We have high density requirements with multiple access points, things along those lines. And then the rest of the 802.11 AC Wave 2 stuff is going to be difficult enough as it is.
Yep.
All right, guys, very nicely done. So here's the challenge. Can you draw out a wireless unicorn? Go.
Oh, a wireless
A
unicorn.
wireless
Yeah.
unicorn? Wait a minute. But a wireless unicorn doesn't have any lines.
Done.
Yeah. Oh, you stole my idea. I was going to draw just the horn because it's wireless.
Okay.
No, now you got to come up with something else.
Which is the better one, though? See,
Mine.
obviously.
Yep.
Awesome.
No.
Well, thank you very much.
Mine has multiple
Oh,
colors.
it's so pretty.
Oh.